Once again, you're welcome back to our online lesson, and today we are going to consider an interesting topic in elective math, and that is binomial theorem. Binomial theorem. Now, what exactly are we expected to know under binomial theorem? Now, this is just a sample of what you must know under the concept of binomial theorem. So you must know something about the Pascal triangle. Then you must know the binomial theorem for positive integer index. You must also know the binomial theorem for rational number index. And you have to also know binomial theorem for negative index. And then the expansion of the form of a plus x all to the power n. And then we'll use it to apply or work examples like linear approximation. So basically, this is just a collection of what you must know under binomial theorem. So without wasting my time, let me explain it detailed so that you understand what we are going to do in general. Now, when we consider what we say binomial, binomial is simply a word used to, or a word given to a two-term expression. It's a word, or let me just make it simple. It's simply a name given to a two-term expression. That is what binomial refers to. And then you have a theorem. Yes, in your own small way, what would you say a theorem is? What is a theorem? You've heard it before. What is a theorem? So when we consider what a theorem is, it's simply a rule or a statement that is true and it can be proven. It is a rule or a statement that is true and it can be proven scientifically or mathematically. So you've heard of Pythagoras theorem, you've heard of circle theorems, and so on and so forth. So they are simply rule or statements that is true and it can be proven mathematically. That is it. So when we consider binomial, as I said, it's a name given to two-term expression. The main topic that we should learn is supposed to be binomial expansion. And from the binomial expansion, that is where we know or we come to learn about binomial theorem. From binomial expansion, that is where we will be learning the binomial theorem, whereby we'll be learning about a rule that can be used to simplify all forms of binomial expansions. Therefore, this concept here falls under algebra. And as I said early on, algebra is the backbone of mathematics. So to begin with, if we are talking about binomial, which we said that it's a two-term expression, I may have a two-term expression like a plus b. And the only time you can expand a plus b, then it means the term is raised to an exponent. So we may have a plus b to the power 0. We may have a plus b to the power 1. We may have a plus b to the power 2. And it goes on and on. So we may have a plus b all to the power n. Therefore, from the basis of expansion or powers of numbers, we learned early on that, or you've come across the idea of power zero. Whenever you have any number raised to the power zero, what answer does it give you? Yes, please.
1.
It gives you 1. Good. So it means a plus b to the power 0 is also 1. And then again, from the laws of indices or powers of numbers, any term raised to the power 1, what answer does it give you?
That same term.
That same
The
term.
same number.
Thank you. So in other words, having a plus b to the power 1, then the answer is still going to be a plus b. Now coming to a plus b, now the powers have increased. So we've gone to power of 2. Mathematically, when we talk about a plus b to the power 2, it means the same number multiplying itself. So we may have the base as a plus b or multiplying another a plus b. That's how the expansion is. And you've learned about multiplication of binomial terms. Then it means you need to distribute whatever is in the first bracket over whatever is in the second bracket. What I mean is that a, which is the first term, will multiply a, and the same a will go ahead and multiply b. Then the b will multiply a, and then the b will also multiply b. So in doing so, a times a will give us an answer of what?
A squared.
A squared. And then a times b, it will give us ab. Then b times a, it will give us also ab. Now, I explained to a couple of students some time ago that whenever you are multiplying variables, you always need to leave your answer in alphabetical order. So even though it is b multiplying a, you write it as ab. And then finally, b times b will give us b squared. Now, there are like terms in there, so we can go further and simplify. And that is going to give us a squared plus 2ab plus b squared. So this is what we have for the expansion of a plus b to the power 2. We can go further to do power 3. Now, considering power 3, having a plus b raised to the power 3, it means you have it as a plus b multiplying another a plus b, then multiplying another a plus b. But we've seen that a plus b multiplying a plus b gave us a solution of a squared plus 2ab plus b squared. Does it make sense?
Yes, sir.
And
Yes, sir.
therefore, this first two factors gives us what is down here. Then the third factor is a plus b. In doing so, going ahead, then we have this a multiplying whatever is in the second bracket. So you distribute each term in the first bracket over each term in the second bracket. So that will be giving us a cube, a squared times b will give us plus a squared b. Then we are done with the a squared distributed over a and b in the second bracket. Now going to the next, 2ab multiplying a will give us, yes, what answer does it give us?
2a squared b.
2a squared b. Very good. Then that the next is 2ab multiplying b will give us 2ab squared. Then we are exhausted the distribution of 2ab over a and b. Now the third one is going to be b squared multiplying a. That will give us plus ab squared. B squared multiplying b will give us plus b cubed.
AB cube.
And therefore, there are like terms in there. And what are the like terms? I believe you can see that a cube doesn't have any corresponding like term, but a squared b
Yes, sir.
has a corresponding a squared b here. and this is 1a squared b. The other is 2a squared b. So what does it give us finally? This two will give us what?
3a
3a squared
squared
b. Very good. And then this and that, they are also friends for which you can add them up. And what does it also give us?
3ab squared.
So we have plus 3ab squared. Good. Then finally plus b cubed. Plus b cubed. All right. I can go on and on and on and on to write the expansions, but you know, there's something you need to actually follow. I believe you've noted the answer here. Now I'm going to another page so that we do some investigation, which generated what we call the Pascal triangle. So watch this. When we had a plus b all to the power 0, that gave us 1. When we had a plus b all to the power 1, it gave us a plus b. When we had a plus b all to the power 2, yes, code the answer. What is it?
a squared plus 2ab plus b squared.
Plus b squared. Good. And then when we had a plus b all to the power 3, yes, what do you have? So a cubed plus
3a squared b.
3a squared b plus
3ab squared.
3ab squared. Then finally plus
b
b cubed. Very good.
b cubed.
Now, there's something I want you to observe over here. There's something, we are going to do a lot of investigations here. So please follow this carefully. I don't want you to chew it. I want you to understand and also apply. All right. Now, let us consider first number of terms after the expansion. Now, for a plus b all to the power 0, the answer was just 1. How many terms did we have in the expansion? How many terms in all did you obtain after expansion?
1.
Only 1 term. Good. A plus b all to the power 1. The expansion gave us a plus b. The power was 1. How many terms did we have in all?
2.
2 terms. Good. The expansion was for a plus b all to the power 2. This gave us a squared plus 2ab plus b squared. How many expansion did we get in all? Or how many terms? Sorry. We had 3 terms. Good. A plus b all to the power 3. It gave us what we have here. How many terms do we have in all?
4.
4. Now, it tells you something. So, in other words, let's do some prediction. What if I have a plus b to the power 4? How many terms are we expecting from what is happening? How many terms are we expecting? 5. Good.
5.
So, what is the clue? For you to know the number of terms you have to generate in every expansion. What is the clue?
Then the power plus 1.
The power plus 1. Very good. If you were very close, I would have given you a lower black and white. So if I have a plus b to the power n, if I want to know the number of terms, it is simply the power n plus 1. Take note of that. That's the first observation. Can we move on to the second observation?
Yes, sir.
Okay.
Yes, sir.
Now, with the second observation, I want you to be focused and then follow, because questions that we ask over here are very dicey. So be very careful. Follow. Don't let anything distract you and follow what I'm teaching. Now, let us analyze the powers of the terms, the powers of the individual terms after the expansion. Now, we can consider a plus b to the power 1. When we expanded, we had a to the power 1 plus b to the power 1. I hope you know that there's a power of 1 here, but it is invisible, right?
Yes, sir. Yes.
Okay, so that is what we had. The highest power in the expansion was the same as the highest power for the question. If you look at it, what's the highest power in the expansion for power 2?
2.
It's 2. The highest power for the expansion for power 3 is what?
3.
Is 3. But this is where I want you to be very careful. Now, the a value was to a power of 1, and then we jump straight to b. Over here, you might not see it so clear, but let's come to the power 2 expansion. We had a squared, then we came to a power of a to the power 1, and then b to a power 1, and then b, the next term had b squared. Do you observe that? So it means you had a squared, the next term had a, and the term that had a had b at the same time. And then we moved on to the third term, which had b squared. Now watch this. Watch this also, the third one. We have a cubed, then we came to what?
A squared.
A squared, then we came to what?
A.
Then we came to, over here there's a there, but that a has a power of 0. Because if you look at it, so you have a cubed reducing to squared, reducing to power 1, and then reducing to power 0. Have you seen the information that I'm passing on? Then the next one,
Yes.
the term that has the highest power for a, it equally has b there, but the b has a power of 0. And the next term will have b to a power of 1, b to a power of 2, and then b to a power of 3, which is the highest power. And you know a is attached to the b cube, right?
Yes.
But it has a power of what?
0.
But what am I putting across here? Whereas the first term, what is happening to the powers of the first term in the expansion?
They are reducing.
They are reducing. What is happening to the power of the second term?
They are increasing.
Yeah.
Very good. They are increasing. So that is another thing you must have in mind. That when you write the expansion, whereas the first term will be reducing in powers of numbers, the second term will be increasing in powers of numbers. That is the next observation. Can I move on?
Yes, sir.
Then the last observation, because from whatever I've told you here, or we've analyzed together, you are going to use that same idea to tell me the terms. Let's forget about the coefficient, but you are going to tell me the terms for the expansion of a plus b to the power 4. You will be telling me. So follow what I'm doing carefully. Now, we said over here it is a cubed b to the power 0, a squared b to the power 1, a b to the power 2, then a to the power 0, b cubed. At the end of it all, another observation is that since the highest power in the question is cube, now when you put the power of the variables together, it should give you the highest power of the question. Did you get what I said?
Sir, please no.
When you put the powers of the two variables together, you should get the highest power of the question. or of the expansion. So over here we had a to the power 3, b to the power 0. We have a to the power 2, b to the power 1. We have a to the power 1, b to the power 2. We have a to the power 0, b to the power 3. When you put the powers of the variables together, it should give you the highest power in the question or of the expansion. Have you gotten it now?
Yes, sir.
So having 3 plus 0, it gives us the highest power as 3. 2 plus 1, it gives us the highest power as 3. 1 plus 2, it gives us the highest power as 3. 0 plus 3, it gives us the highest power as that. So there are 3 observations we've made here. One is, whereas the first term reduces in powers, the second term increases in powers. The next that we came up with was
the number of terms can be found by adding 1 to the power.
exactly, very good. The number of terms plus 1 will give you the highest power plus 1 will give you the total number of terms in the question. Are we all okay now?
Yes, sir.
So now let's do something here. It's not magic. I don't want you to chew. It is not magic. So we've already estimated that for the expansion of a plus b to the power 4, we are expecting how many terms in all?
5.
5. So let us begin. Let us begin writing the terms. Let's forget about the coefficients. If maybe I use the cube, maybe the squared can also give us the same thing. This is a squared b to the power 0. This is a to the power 1 b to the power 1. This is a to the power 0 b squared. So at the end of the day, it gives you the total power, sum of the power as 2. So let us begin. What do you think will be the first term? Just forget about the coefficient. Just give me the combined terms for a plus b to the power 4. Forget about the coefficients. Just tell me the variables and their powers. The first term, what will be the variable?
A to the power
A to the power 4. Very good. Plus, forget about the coefficient. I'll come to the coefficient later on. Yes,
Power 3.
a to the power
A to
3.
the power
A to the power 3b.
Thank you. A to the power
B.
3b. Then the next one will be what?
A squared
A to the power
A squared
B squared.
b squared. Very good. Plus, next one will be
A b to the
A
power
a b cubed. Very good. Then
b exponent 4.
b exponent 4. Clap for yourself. That is so wonderful. That is so wonderful for being able to write the variables. Being able to write the variables. Can we go to another magic? Who is actually
Yes, sir.
okay? I believe no one is lost. So moving on to the next, let's write down the coefficients. Let's write down the coefficients. Now for the expansion of a plus b to the power 0, we had only one coefficient, which is 1. For the expansion of this, we had a plus b. The coefficient of a is 1. The coefficient of b is also 1. For the expansion of a plus b all squared, the coefficient of a squared is what?
1,
The coefficient of ab is what?
2,
2.
And then the coefficient of b squared is what?
1.
Okay. Now coming to the a plus b all cube, the coefficients will be, yes,
1. 3.
3, 3.
1.
thank you. Now watch something here. As I said, it is not magic. So watch. We are going to generate the coefficient of a plus b to the power 4. Are you ready for it?
Yes, sir.
Yes, sir.
Okay, so here it is. Watch. This is how the coefficient is going to be generated. Now, this is how the first coefficient, you just repeat this here, and then you just repeat it there. When it comes here, you repeat what is here, but you add on this to that to give you what is here, and then you repeat the last. Did you see what I did?
Sir, please, can you come again?
Oh, then I have to clean whatever I've started with. Okay, don't worry. Watch carefully. I'm going back. That's why I've told you, don't let anything distract you. Immediately you get missing, unless you find yourself. We've written down the coefficients for the first 3 expansions. We want to use that idea to generate the expansion for the 4th one. So I said you just simply have to repeat your 1 here and repeat the 1 also there. Now, so the first and last is always repeated, but the next is going to be added on. Therefore, we repeat the 1 here and we add on the 1 to whatever we have here and write the answer down here, which is 2. And then we repeat our 1 here. Have you seen it? The next is we repeat our 1 for the first, add on the 1 to the 2. What do you have?
3.
Add on the 2 to the 1. What do you have?
3.
Does this have anything to be added on to?
No.
So what do? We just repeat it.
Right.
So let's begin. For power 4, we are writing the coefficient. So this is the beginning of the journey. So we just write the 1 down. Add on the 1 to the 3. What do you have?
4.
You write the 4 down. Then add on the 3 to the 3. What do you have?
6.
Add on the 3 to the 1. What do you have?
4.
4.
And then does this has anything to be added on to?
No.
So we have what?
1.
Okay. So that is the coefficient of power 4. Let us go to power 5. Yes, what are we going to have? Smartly. Let's go. Keep on. 1.
1. 5.
5. 10.
10.
10.
10. 5.
1.
1.
Thank you. Then going to the next.
1.
1.
6.
6.
15.
15.
20.
20. 15. 6.
6.
And 1.
1.
All right. So these are the coefficients generated from the expansion of a plus b. So we have power 0, power 1, power 2, power 3, power 4, power 5, power 6. You can even go ahead and write the coefficient for power 7. So from whatever we've written here, so power 4, please watch this. Power 4, the coefficient of the first term is a to the power 4 will be 1. But for a cube b, what will be the coefficient?
4.
Then the next term, a squared b squared, what will be the coefficient?
6.
Then a b cube, what will be the coefficient?
4.
Then finally, the coefficient for b to the power 4 will be what? 1. So
1.
that is what is there. And this idea here is what we call the Pascal triangle. That is what we call the Pascal triangle. One mathematician or scientist by name Pascal generated this idea, which is used to write the expansion for any given binomial term. Please, are we all clear?
Yes, sir.
Do you want to get to know why the answer still is this? So that we do it so that it confirms that whatever Pascal brought on board and whatever expansion we have, it will give us the same idea. Do you want us to do it as we work out a plus b all to the power 3? Do you want us to work it out to see if we get the same answer? Yes, no, I need response.
Yes.
Okay, so let's do it together. So having a plus b all to the power 4, we know that a plus b to the power 4 is the same as a plus b to the power 3 times a plus b. The reason why I'm writing it this way is for the fact that we already know the expansion for a plus b to the power 3, so that we don't waste our time doing them all over again. So a plus b all to the power 3, we've learned that it gives us an answer of a cubed plus 3a squared b. Yes, continue.
Plus 3ab squared
Very good. Plus
plus b cubed.
b cubed. Very good. Multiplying the next factor, which is a plus b. So when you distribute all the terms here over a plus b, which is in the second bracket, it means a cube will multiply a, that will be giving us a to the power 4. Does it make sense?
Yes.
Yes, sir.
A cube again will multiply b, that will give us plus a cube b. Then we have exhausted the a cube distributed over a and b. So we go to the next step. 3a squared b will multiply a, that will give us plus 3a cube b, right?
Yes, sir.
Then we have 3a squared b multiplying b, that will give us plus 3a squared b squared. Does it make sense?
Yes, sir.
Okay, so I have done the first two expansions. Let us multiply 3ab squared by a and b. What answer are we getting? 3ab squared multiplies a. What do we have?
3a squared b squared.
3a squared b squared. Good. Then 3a squared b 3ab squared multiplies b. What do we have?
3ab cubed.
So we have plus 3ab cubed. Good. I'm so happy you guys are really following. I'm so grateful. And then we come to the last term in the first bracket. B cubed multiplying a and also multiplying b. What are we having?
B exponent 4.
So b, did I hear b exponent 4 directly? The b cube will multiply a and multiply b. So what do you have?
B cube A.
It is
Or A
a
cube.
b cube. I remember telling you that you should write it in alphabetical order. Then b cube multiplies b, we have plus what? B to the power 4. So it's just obvious. At this point, a to the power 4 doesn't have any like term, so we still have it as a to the power 4. Now a cube b plus 3a cube b, that will give us plus what? 4a cube b. Does it make sense?
Yes, sir.
Yes.
And then plus 3a squared b squared plus 3a squared b squared. That'll give us what? 6a squared b squared. Good. And then 3ab cubed plus ab cubed. That'll give us what?
4.
4ab cubed. Then finally plus b to the power 4. Good. So you see that it confirms it.
Yes, sir.
So with the idea of Pascal triangle and the characteristics of expansion, then you should be able to expand any binomial term raised to a positive exponent. Any binomial term raised to a positive what? Exponent. And what are some of the characteristics that we observe? Yes, they are.
The number of terms is equal to the exponent plus 1.
Okay. The highest power plus 1. Okay. And then we also found out that whereas the first term will be reducing in power, the second term will be increasing in power, which is very key. Very, very key. Very key. So please, my dear students, let us be very careful with that. Now, without much ado, let us apply just the little that we've learned right now to work on. And the little we've learned right now, let's take it that we are told expand x plus 2y all raised to the power 3. Expand x plus 2y all raised to the power 3. So in doing so, we just learn something that you need a coefficient, which is very key in the expansion. And you should estimate the number of terms altogether. So from Pascal triangle to the power 3, what is the coefficient? Yes, let us note it down. What's the coefficient for power 3?
1,
1,
3,
3,
3,
3,
3.
and 1. That is the coefficient. So watch. So having x plus 2y all to the power 3, this is equal to, you can go ahead and write down the powers of this expansion, like for each term, before you bring in the coefficients. And what are they? We should have x to the power 3 and 2y to the power 0. Then plus, okay, maybe let me put it that way so that you understand it better. So x to the power 3 but 2y to the power 0 plus x to the power what?
2.
2. And then 2y to the power what?
1.
Good. Plus x to the power what? 1. Then
1.
2y to the power what?
2.
Then finally, we have x to the power 0 and then 2y to the power what?
3.
3. Good.
3.
Then being able to write the powers of the terms, then now you can attach their corresponding coefficients. What are the coefficients? We found out that the first term will have a coefficient of 1, the second term will have a coefficient of 3, the third term will have a coefficient of 3, the fourth term will have a coefficient of 1. So let's simplify. Let's simplify. Now 2y all to the power 0 is what answer?
1.
1.
1. Then we have 1 times x to the power 3, then times 1, plus 3 x squared. Now 2y to the power 1 is the same as 2y. Are we all okay?
Yes, sir.
Then plus 3 multiplying x to the power 1 is still 3x. But 2y all raised to the power 2, what answer does it give us?
4y
4y squared. Very good. Then plus x to the power 0 is the same as,
1.
so we have 1 times 1 multiplying, yes, 2y all to the power 3. What's the answer? The 3 will affect the 2 and also affect the y. So we get what? 8.
6y cubed.
Six.
Did I hear
6.
6? Did I hear
8.
6?
8.
8y cube.
So it is 8y cubed. It is 8y cubed. So finally, the expansion for x plus 2y all to the power 3 is giving us x cubed plus, you can multiply the coefficients. So the coefficient is going to give us 6x squared y. Over here, the coefficient can multiply, so that will give us 3 times 4, which is 12x y squared. Then the coefficient of that will also multiply, get plus 8y cubed. So this is the expansion for x plus 2y all to the power 3 from the help of the coefficient of Pascal triangle and the characteristics of each term in a given expansion. Any question, please?
No, sir.
Good. I believe you are following carefully and you are enjoying it.
Yes, sir.
Good. So I want you to try one for me. Just try one for me. It's not always that it's going to be addition. Sometimes it might be subtraction, but you should be able to work it out from whatever we are just doing here. X minus y all raised to the power 4. What is going to be our expansion? X minus y all raised to the power 4.
Sir, please, I'm done.
Great. Very good. Can you share your answer with us?
Sir, please, I had x raised to the power 4 minus 4x cubed y minus 6x squared y squared minus 4x y cubed minus y raised to the power 4.
Okay, can you take your time and then say it again? I'm writing it down. So x to the power 4 minus
4x cubed y minus 6x squared y squared minus 4x y cubed minus y raised to the power 4.
Are you sure this is right? Okay, you said that's what you had. You are not sure, right? You don't know whether it's right or not. Don't worry. Yes, any other?
Sir,
Yes, please.
it's a go x cube.
Did you say s cube? Because the power is
Yes.
4.
Minus
The highest power is 4.
8. Sorry. X to the power 4
X to the power 4.
minus 4x cube y plus 6x squared y squared
Yes.
minus 4x y cube plus 4 is the plus y is the power 4.
Good. Thank you very much for your submission. Any other? Okay. So based on experience, we have a question mark on the first one, and we may not have a question mark on the second one. So I'll say that this is right. My dear gentleman, do you know why you got it wrong?
Sir.
Do you know why you had it wrong? Or do you know why there's a question mark on your solution?
No.
Okay.
Sir, please.
All right. So I'm going to do it together with you to confirm that whatever we have for the second is right. Now you should be very careful. Have you seen the way I wrote the expansion over here? Wherever I have any negative or whatever, I need to put it in brackets. And the power affects the whole factor altogether. So you should be very careful. Now, so we had a question as x minus y all to the power 4. So in the first place, we need to know the Pascal triangle for power 4. And we just learned that the Pascal triangle for power 4 is 1, 4, 6, 4, and 1, right? And based on our observation in expansion of powers of numbers, we learned that the first term will be reducing in power whilst the second term increases in power. The first term is x, but the second term is negative y, not just ordinary y. The first term is x, the second term is negative y. So the first term will be x to the power 4 negative y to the power 0 plus the first term is reducing in power, so that will give us x to the power 3 negative y to the power 1. The next term will be plus x to the power 2 negative y to the power 2. Please, are you all following?
Yes, sir.
Yes.
Plus the next term will be x to the power 1 negative y to the power 3. The next term will be plus x to the power 0 negative y to the power 4. So being able to write down the powers of each term, then I need to consider putting the coefficients in front of them. And that will be having 1 here, 4 here, 6 here, 4 there, and 1 here. Expanding and simplifying, negative y to the power 0 is the same as 1. But this will be left with 1x to the power 4. Over here, negative y to the power 1 is the same as negative y. But this will be giving us 4x cubed. Then we'll put our plus sign here. Remember the negative sign is there. I'll write the final answer later on. Then this will give us plus x to the power 2 will be 6x squared. Over here, negative y all squared becomes a positive y squared. And that will be giving us plus 4x negative y cubed. Then plus 1x to the power 0 is 1. But negative y to the power 4 will become a positive number. So we have 1y to the power 4. So finally, over here, we'll have s squared s to the power 4 minus, because of the negative sign here, or negative 1 coefficient for y, we'll have minus 4x cubed y. This one, everything is positive, so plus 6x squared y squared. And finally, over here, there's another negative sign affecting the coefficient of y. So we have negative 4x y cubed, then finally plus y to the power 4. Please, are we all okay?
Yes, sir.
All right. So let me see if we have more time. No, our time is almost up. But let me just introduce something to you which will help you to generate all the coefficients without going through the stressful Pascal triangle. How to generate the coefficients without going through the Pascal triangle. Now, watch. We had 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You see, it's like you are chewing. You've memorized and then you are actually quoting them. But all this thing can be done away with by just simply using a tool known as combination. The combination tool is on your calculator. On your calculator, it's been shown as n combination r. Please check on your calculator. Have you seen where the n combination r is?
Yes, sir.
Very good. So let me display my calculator so that I can also use it to help you understand how to apply the n combination r.
Yes, sir. You are right.
Okay, so before I move on, just program on your, please, are you all here so that we do it together, because I don't want us to waste my time. I'm explaining it before I bring on board my calculator. The n refers to the power in the question, power of expansion, the power in the expansion, the highest power in the expansion or in the question. That's what the n refers to. The r refers to the terms, the terms in the question. Now we found out that when it comes to power 0, how many terms do we have? Only one term. When we have power 1, we have 2 terms. When we have power 2, we have 3 terms. When we have power 3, we have 4 terms, and it goes on and on and on. So for instance, when I'm considering the question, let me take the third one. There's the third one. A plus B all raised to the power 3. I'm expecting R value to begin from 0, R value to go to 1, R value to go to 2, and then R value to go to 3. Even though you are having R value beginning from 0, how many R values did you obtain in all?
4.
We have 4 R values, and that represents the 4 terms you are expecting in power 3. The 4 terms you are expecting in power 3. So here it is. The highest power in power 3 is 3. So the first term is going to be 3 combination 0. The next will be 3 combination 1. The next will be 3 combination 2. The next will be 3 combination 3. And program it on your calculator. That is going to give you the answers as the 1, the 3, the 3, and then the 1. Please, have you done that? So
Yes,
the combination symbol is found at the division sign. Look at the division sign. So let me clear my mode to mode 1 computation. Have you seen where the NCR, have you seen it, where the division sign is?
Yes, sir.
So as I said, we are looking at how to generate the coefficient using the combination formula or rule. Therefore, for the highest power of 3 expansion, you expect 4 terms. N is going to be 3, but the R values will begin from 0 all the way to 4. Sorry, all the way to 3. And then it will give you the 4 terms altogether. So here it is. You key in 3 shifts and that. Then you key in 0. Then you press equal to. So it's 1. Then you go again. You can edit it, or you can clear the whole screen and then go for the next term. That is going to be 3 shift combination 1. And that will be the second term. That will give you 3. And then you have 3 shift combination 2. So that will give you what? Another 3. Then finally 3 combination 3. That gives you an answer of what? 1. Have you seen it? So that is
Yes, sir.
how you can generate your coefficients for your expansion. Now let us do that of the 4. How many terms do you have in all for expansion of power 4? How many terms do you have in all?
5.
5. Therefore, the R value will begin from what number?
4.
R value will begin from what number?
0.
And then end at what
0.
number?
4.
And end at 4. So watch this. It's going to be 4, that is the end value, shift combination 0. That's for the first step. The answer is 1. 4 combination 1. The answer is what? 4. That is the second term, coefficient for the second term. Then you have 4 combination 2. Yes. What's the answer? 6. I hope you remember it was 6.
Yes, sir.
Then we have 4 combination 3. And that is giving us what? Another 4. Then finally 4 combination 4. And that'll give you an answer of 1. So 1 4 6 4 1. Even though we've not done the 5, you can test for 5 and it works. So that is the tool I'm going to leave the lesson with. Practice it. I'm going to send some questions for you to try and answer them and then give me a feedback. Please, I hope I'm clear.
Yes, sir.
I'm so grateful having you, and we shall meet, God willing, another time for our lessons. Have a great day, and God richly bless you. Bye-bye.